Okay, so here's the third page. We'll just go ahead and skip to this. Third page here starts out with two graphs that are given to me, and I have to figure out the equation and a bunch of info about the graphs. First thing I want to do, if there are basically three things I need to figure out if I'm doing the equation. And let's just look at this down here. This is what's been on the board. We've got, after y equals, we've got whether or not it's a plus or minus. Then we've got the number in front of the absolute value. And then we've got the things that are plus or minus. That's the h and the k. The plus or minus out front is all based on whether it opens up or down. Okay? The number behind that is what a lot of people have trouble with. The number behind that is basically rise over run. And it doesn't matter what the sign is because we already have the sign out here. The sign is taken care of right here. So it's basically I'm figuring out how much I have to go up or down to go from one point to the next over how much I have to go left or right. And again, it doesn't really matter whether it's left or right. It doesn't really matter if it's up or down. Because normally if we're doing a line, we would do slope that way, and it would matter up would be positive, down would be negative, and so on. But we're not really concerned with the sign because the sign is already taken care of out here. Okay, then the h and the k is the vertex. All right, so looking at number 18. First thing is it opens down. So that means right behind the y equals, you have a negative. That's the first thing. Second thing is I have to figure out that how much it goes up and down for every how many it goes right or left. It might help if we zoom in a little bit on this one. Oh, we can't. Okay, if you look at this, it goes down 2 and right 1 to get to another point that's on the grid lines, or down 2 and left 1. It doesn't really matter, again, if you're going up or down or left or right. What matters is how far the y changes, which is 2, for every 1 the x changes, or for how many ever times the x changes. To get from one point to the next, the y changes by 2 and the x changes by 1 each time. If you want to, you can just look at one side of the graph because the two sides are going to be identical. So it's kind of like you're finding the slope for one side of the graph and then saying, I don't care what sign it is. So this is a 2. Then I have to figure out where the vertex is. For this one, it's at -5, -3. So that means I fill that in. -5 goes here, so x minus -5 is x plus 5. And this is -3. So I have x plus 5 and minus 3 out back. So that is my equation. Let's go ahead and do the same thing for number 17, just to reinforce what we're saying. First thing is if it's up or down. If it's up, it's positive, and it is. Second thing is the slope. Let's just figure out one side. It goes up 1, right 1, up 1, right 1, up 1, right 1. So it's just 1. So I don't even really have to write it. If you wanted to write it, it'd be a 1. You don't have to write it. Then I'm going to look at where the vertex is. It's at 1, -4. So that means x minus 1 plus -4. So that's why inside here it's the opposite sign from what you see. In other words, it's a positive 1, so it's -1 here. And then -4. And that's my equation. All right, going back to number, it says 18. I'm sorry that 18 is above 17. But going back to number 18, okay, the vertex is right here in the middle. -5, -3 is right there in the middle. That's also where the axis of symmetry is. The axis of symmetry goes right down the middle. The axis of symmetry here would be x equals -5. So that means everything on this graph is either on the left of x equals -5 or it's on the right of x equals -5. So that's how we describe the left and right. The left would be x is less than -5, The right would be x is greater than negative 5. And then we tell whether it's increasing or decreasing on each side. So one of the sides is x is less than negative 5, and one of the sides is x is greater than negative 5, because negative 5 is where the axis of symmetry and the x value of the vertex is. It's always going to be less than the h or greater than the h for the two sides. So let's just say that down here. Like as a general rule, okay, if it's opening up, here is my hk, then this is x is less than h. The less than and the greater than are about right and left. They're not about whether it's going up or down. So less than's always left, and greater than's always to the right. Now, if somebody's standing on top of this, they're sliding down. So that's decrease. This is a hard climb, so that's increase. Every time it opens upward, it's going to be like that. X is less than whatever the h value is of the vertex is a decrease. And x is greater than whatever that is increase. If we turn it over and do it upside down, v instead, still hk. Left is still x is less than, right is still x is greater than. But this time the person climbing is on the left and the person sliding down is on the right. So this is the increase now, and this is the decrease. So these two really apply to all cases. It's either like this or it's like this. So this first one up here, it's upside down. The x value is negative 5 for the vertex. So on the left-hand side, which is x is less than negative 5, it's an increase. Just like this one right here. Left-hand side, it's an increase. Right-hand side, it's a decrease. So this is increase. This is decrease. And I'm going to put x is less than negative 5 here. And x is greater than negative 5 here. Now rate of change to the left and right, rate of change is like slope. And here the signs do matter. It's just saying, basically, take this number, the number that's like slope, and tell me which side it's positive that number or which side it's negative that number. So in other words, this is going up. If it's increasing, it's a positive slope. So that's positive 2 on the left. And if it's decreasing, it's a negative slope. So that's a negative 2 on the right. The rate of change is just like slope. And so it's going to be just like this number here.
So it's asking which side it increases.
It's kind of, yeah, I mean, we have to, there are two things we have to recognize to do this. One is that rate of change means the same thing as slope, and that that's going to be the same as that number. And the other thing we have to recognize is if it's positive, that's on the same side that it increases on, and it's negative on the same side that it decreases on. Now in number 17, which comes after number 18 for some reason, first thing it asks is where is the axis of symmetry? It's x equals 1 because it's always x equals whatever the x value is for the vertex. So since h is 1, it's automatically x equals 1. The y-intercept you can look at means where my graph crosses the y-axis, where that bold line crosses the y-axis. So looking here, it looks like it crosses at 3. So I'm going to write 0, 3.
It would be 0, negative 3.
I'm sorry, it would be 0, negative 3. Thank you. Okay, looks like it's at 0, negative 3. It's right here between negative 2 and negative 4.
You have to put 0, negative 3.
You can put negative 3 or you can put 0, negative 3. I would prefer 0, negative 3, but I will give you credit if you put negative 3. Zeros, same thing. Zeros means x-intercepts. That's the first thing to get there, is that you understand the zeros means the x-intercepts. Okay, x-intercepts should always be some number comma 0. But again, if you don't do that, if you don't write it in order pair, I'll still probably count it. So here's 1. There's one place it crosses the x-axis. That's at positive 5. So that would be 5, 0. It also crosses the x-axis at negative 3. So it's negative 3, 0. And again, if you just put 5 and negative 3, I would accept it. but I would prefer that you know to have put those in an ordered pair. Okay, extrema means max or min value, maximum or minimum. Okay, and it's about the y value. If your V is opening upward, then the vertex is automatically the bottom point. So that would be a min. So if you have a regular looking V, then you have a minimum, and you look at what the y value is and you say, that's it. If you had an upside down V, then you automatically have a maximum. It's like a mountaintop. And again, you look at the y value and you would say, okay, that's what it is. So this one up here would have a maximum value at -3. This one down here has a minimum value at -4. There you go. Excuse me. Okay, last part here. Last part is a piecewise function. It's got 2 pieces, so I'm going to do 2 tables of values. Now this is a good what if because the first one is kind of weird. Okay, the first piece is 3x plus 1. Second piece is y just equals -2. The weird thing about the first piece is it only goes from 1 to 2. So it's like, well, what else am I supposed to put in the middle? You don't really even have to do anything in the middle. You could do 1 and 2, because remember, it only takes 2 points to figure out a line. So I can do 1 and 2. On the side where I have 1, is it closed or open? Closed. If you have the or equal to, it's colored in, because it can equal to. On the right-hand side, though, it's open. So I'm going to put, this is going to be open, because it can't actually equal 2 on this graph. Can it equal 2 over here? Yes. This says x is greater than or equal to 2, so I'm going to do 2, 3, and they're all closed. Keeps going. This one doesn't keep going in any one direction because you have x is between 2 numbers, so it's got a boundary on both sides. It's like it has a wall on both sides. This one only has a wall on one side, so it keeps going on the other side. So that's why I put an arrow there. So this one, the first piece, I'm going to plug in 1, and I get 3 times 1 plus 1, and that's 4. And I'm going to put a closed circle at 1, 4. That's right here. Then I'm going to go ahead and plug in 2, and I get 3 times 2 plus 1, which equals 7. And this is the open circle, so I go to 2, 7, and I put an open circle there. And then I can connect them. Nope, I'm done on both sides because the x's are only between 1 and 2 there. So I just connect those like a little segment. If you have an x between 2 numbers, it's going to be a line segment, not an arrow. Okay? Then this one, this is one of those, what kind of line is that? Horizontal or vertical? Horizontal line. And that means y is always -2. So it doesn't matter what x is, y is -2 always. So I start at 2, -2. It's colored in there. And then I keep going. 3, -2, 4, -2, and so on. It's going to be a horizontal line forever in that direction.
So
And that's
if
the
it was a vertical line.
If it was a vertical, we wouldn't have a vertical line on this, honestly. There won't be a vertical line. So that's the last page.